Okay, this is my final project for embedded controller hardware design. And it is a simulated 3D printer using a Delta Arm configuration. And here is the Delta Arm. I built all of the parts, or assembled all the parts. I built anything you see here out of wood, but obviously I bought the hardware and stuff from various places. So how it works is that this traveling base here stays parallel with this stationary base plate here, and it moves by changing the angle of each of these servo motors. So if you can see, when this base moves, these all move at different angles. And then for it to go up or down, the angles all go up or all go down. So by calculating the angles on these servos, you can find positions for the base to move to. And that turned out to be the complicated part. The building is actually, these farless pieces is inherently parallel because of the way it's set up. These linkages here may constrain the system so that it has to remain parallel. And it runs off of only 3 servo motors. Unfortunately, those servo motors have to be a lot larger than what you see here. To get these to work in even limited fashion, I had to give them each an extra ½ amp, and I gave them extra 2 volts too, which is well outside the range that they'll be running at. So this demonstration will have to be fairly short. And to run it, using this Arduino and a couple of L298N dual bridge drivers. There's 3 of them, 1 for each servo, controlled by 4 pins each on the Arduino, and that made me use the analog pins here as digital ones. These 2 LEDs here are supposed to be for the extruder and the limit switch. The limit switches are for the arms being in position first and the bounds of position. So each of these arms should have a limit switch in both the in both directions, so that you can figure out a when the thing is trying to travel out of range, and B when the on the very first start where these arms are located, as they're steppers, not servo motors. So I simulated that with a contact switch there and these LEDs. The other one is supposed to symbolize the extruder, and it's off of a pulse width modulated pin here. And while it's operating, I'll show you that moving, or dimming and brightening, as if the extruder would be controlled to control the speed of the extruder with the speed of the traveling base. Things get really hot since I had to give these servos a lot more power than they're rated for. And even then, as you can see, the servos have a decent amount of leverage on the system when the leverage or the lever is down more. And as soon as it gets about to here, the servos just start skipping steps, and well before you can't have any accurate movement. So you're really limited here, about 13, 14 steps in either on either servo, which gives you a limit of about like 5 centimeters in terms of where this base can move accurately. And I still use accurately in terms of relative to when it's out here, not accurately as in this thing can actually put out a 3D part without significantly stiffening the system and adding better servos. But even then, just because of the geometry, this could be capable of fairly accurate movements, especially if I was able to bring these into the higher torque zones, because it would mean that a very small amount of movement here would mean a very large amount of movement down there, and then vice versa. Obviously, if you keep it closer to the ground, this movement takes a lot more degrees to move it than this movement. So it kind of ramps that way. So this system's capable of very accurate movements in a certain range and very fast movements in a certain range. And powering it all, I have this power supply, which I maxes out with the current and voltage draw for these servos at 5 amps, which is half an amp over the amperage that these things should be able to take. And actually I had to set up a couple batteries to run a fan while I was testing the thing. So I can't actually run these things long at all, but enough to do a small program. Let me turn on the power and make sure these are in the right position. All right, and that and you can see the limited travel that I have. That's about the max limits. That actually travels to all the corners, and it's not a square that it travels in. It's kind of a strange circular shape, which should be in the report. And while it's doing this, it's outputting to the screen the current position and the next moving positions. And that's when it tells you program end. All right, and then one more time from the extruder and limit switch perspective. And you'll see the right LED dim and brighten while the program's running. And that's to simulate the extruder having to extrude faster or slower based on the movement. And the other one is if the limit switch was hit, it would signal to the Arduino that it had hit the limit. Right. And then included with the program, I found that the memory was very limited if you wanted to do these kinds of movements. I had to load in into its memory. Turn off this power. Memory itself of the Arduino. I think a secondary memory, at the very least for buffering, would be necessary, which I didn't incorporate into the design and should have, because there's no way to do a print through the Arduino that way. You'd have to have the computer drip feed into it, which I also did a separate Arduino sketch. Now the drip feed version. And that should be included in the report as well. And now, whenever you type in on the serial port here a series of 3 numbers, it will move. Turn this power real quick. And so the drip feed is a common CNC technique for limited memory controllers, in that the computer does all the memory, all the calculation, it does everything on its side, and the controller only does servo or stepper management. And I believe the second program is going to be the one you'd have to use if you were going to use this as a 3D printer. And what you would do is you just drop a array into the serial port. 3 integers plus a new line character is the protocol that it currently got programmed in. But I made it so that obviously you can test it using the Arduino serial port, which is limited in that you can't drop a text file like you would on a CNC machine. Anyway, that's it for the final project.